learning outcomes. At the end of the session, the students shall be able to compute the variation, deviation, and compass error. Students also shall be able to understand and know how to compute compass corrections, measuring relative bearings, and shipboard compasses. Examples 2 and 3. If the variation is 3 degree S and the deviation is 2 degree S, calculate the compass error. Solution. Variation equals 3 degree S, deviation equals 2 degree S, compass error equals variation plus deviation equals 3 plus 2 equals 5 degree S. If the variation is 4 degree west and the deviation is 2 degree S, calculate the compass error. Solution. Variation equals 4 degree west, deviation equals 2 degree S, compass error equals negative 4 plus 2 equals 2 degree west. Examples 4 and 5. If the compass bearing equals 0.52 degree C, variation 4 degree west, and the deviation equals 1 degree S, calculate the true bearing. Solution. Variation equals 4 degree west, deviation equals 1 degree S, so the compass error equals 3 degree west. To get the true bearing, kindly subtract the compass bearing to the compass error. Compass bearing equals 0.52 degrees C, compass error equals 3 degree west, so the true bearing equals 0.49 degree. If the compass bearing is 0.28 degrees C and the true bearing is 0.25 degree T, find the compass error. Solution. True bearing equals 0.25 degree T, compass bearing equals 0.28 degree C, so the compass error equals 0.03 degree west. So take note, if C is less than T, the error is S, and if C is greater than T, it is west. Deviation, ship-specific error. Due to onboard magnetic influences, magnetic items to which magnets are attracted, wires carrying DC electrical current, reduces effects as much as possible. Keep compass away from influences. Twist nearby DC wire first. Usually can't eliminate them all. Additive effect of compass errors. So the blue arrow is the true north and the violet one is the compass heading must be adjusted 0.20 degree to compensate or your desired true heading. The sky blue arrow is the error due to 0.15 degree west variation, and the green one is the additional error due to 0.05 degree west deviation. Measuring deviation yourself. By using deviation table or curve, we can obtain the deviation value of a specific compass course. First, you have to know how to do some compass calculations.
Compensations. Deviation often greater than 10 degrees. Special magnets, compensators, installed in compasses to reduce error. Most compasses with the instructions can still have significant deviation error after having compensation. Computing compass corrections. True heading 000 degrees. Variation in chart 015 west. Magnetic heading 015. Deviation 005 west. Compass course 005 west. Computing 020. So this is the worldwide variation First is the isogonic chart, illustrate magnetic variation in 1995. Swinging ship, process of measuring residual deviation error after having compensation. Usually determined in 15 degrees to 30 degrees heading increments. Recorded in front of the deviation table, compass adjuster can provide service, or you can do it yourself. So back to the measuring deviation, for each 15 to 30 degrees, you need to know exact what directions the magnet specifically is magnetic. Your boat is pointed. Compare with the compass reading, compute the deviation. Key to puzzle is knowingly exact what directions you're headed. There are several ways. Example way to know your heading is in calm water with minimal current, remaining in the vicinity of Aton, record both compass heading and relative bearing every 15 degrees to 30 degrees. Compute the deviation for each heading. As you can see, means to take the relative bearing. As you can see, there's illustration, known directions, and also close to reliable Aton.
Measuring relative bearings. So measuring relative bearings are mounted parallel to the vessel's keel with all-around view. Also, 0 degrees aligned with keel and align targets and sights, and read relative bearing and scale. Electronic steering compasses. Electronic steering compasses featured automated deviation elimination. Local magnetic disturbances. Compass still seems wrong. In some locations, there are local magnetic disturbances that can affect your compass, often noted on charts. Shipboard compasses. The gyro compass has 3 axes: spin axis, torque axis, and precision axis. As centrifugal force of the Earth's rotation, tangential velocity, acts upon the gyro, and the torque and precision axis will react and keep the spin axis oriented to a terrestrial meridian. The gyro compass. The gyro compass has several advantages over the magnetic compass. It seeks true or geographic meridian instead of magnetic meridian. It can use near the Earth's magnetic poles where the magnetic compass is useless. It is not affected by surrounding material. Its signals can be fed into inertial navigation system, automatic steering system, and fire control system. Being a complicated electronic instrument, the gyro compass has some disadvantages. It requires a constant source of electrical power and sensitive to power fluctuations. It requires periodic maintenance by qualified technicians. Methods of determining gyro compass error. Although the gyro compass is a very accurate instrument and normally has a very small error associated with its reading, 0.1 to 0.2, the navigator is required to determine gyro error at least once a day. Gyro compass error, like magnetic compass error, is measured in degrees east or west. The first illustration states that if the gyro compass bearing is higher than the actual bearing, the error is west. The second illustration states that if the gyro compass bearing is lower than the actual bearing, the error is east.